I'm going to zoom mine in so I could see it a little bit better. So these are text boxes. You can type in them. We're going to talk about a little bit of literal equations, then we'll get into actually solving some. All right, so literal equations, by definition, what are they? They are equations that have more than one different variable. If you click on the little magnifying glass, you can click like 100, 200%, whatever it is. So literal equations, equations that have more than one different variable. Now our goal when we are solving literal equations is going to be to solve for the variable asked for in the problem. So you can kind of see there with example 2, you can see that that equation has multiple variables in it, and they're asking you to solve for a specific one. So you're trying to get that specific variable by itself. So when you get your answer is more than likely going to have multiple variables in your answer. All right, so here we've got our first example we're going to look at. We've got negative 2x plus 5y equals 12. So I would, if I were you, I would work this out on your notebook paper. And trying to type those math symbols in is going to take forever. So in this problem, example 1 here, it says solve for y. So we're trying to get y by itself. So here's my y right here. I want to get that by itself. How do you think we might start to get y by itself? I couldn't hear you. What'd you say? All right. So, okay. So I don't know if we want to work with the 5 yet. Think about you're trying to get this by itself. You want to work farthest away from that variable first. So we want to start here with this minus 2x. How am I going to move that to the other side? How am I going to move the minus 2x to the other side?
Plus 2x.
Plus 2x, yep. So we're going to add 2x to both sides. So those would cancel. The 5y is going to come down. Now, are 12 and 2x like terms? No. So I can't directly add those together, but I can rewrite them together. So I would rewrite them as 2x plus 12. I can't directly add them together, but I can rewrite them. You could have also written it as 12 plus 2x. That would have been fine as well. Now we're still trying to get that y by itself, so how are we going to get rid of the 5? So this is 5 times, it's 5 times y. And this is like saying 5 times y. So how do you get rid of the 5? Got to do the opposite. What's the opposite of multiplication? Division. So I'm going to divide everything by 5. So I divide the 5y by 5, that cancels out. Bring down my y. Does 5 go into 2 evenly?
No.
No, so I'm just going to rewrite this as 2/5 x. All right, I'm just going to keep it as a fraction. Does 5 go into 12 evenly? No. So we're going to keep that one also as a fraction as 12/5. So this is my final answer for solving that equation for y. Getting the y by itself. And notice that my equation still has an x in the answer. That's okay. That's what's going to happen with these literal equations. They're going to leave more than one variable in your answer. Any questions there on that first one? Okay, I'm going to go back up. This number 2 is up here. All right, here's example number 2. All right, again, I'd write this one on my own paper and solve it out as we go. So this one has y equals x minus m over b, and they want us to solve for x. So we're trying to get x by itself. So here's my x. I'm going to get that x by itself. How would I start solving for x? Trying to move everything else to the other side. Say that again. Subtract what? All right, so we don't want the x to move. The x is staying there. We want everything else to move. Did you say subtract x? All right, let's say that it had been this. What if it had been y equals x minus 3 over, I don't know, 2, we'll say. Let's say instead of m and b, they had been 3 and 2. How would you start solving that for x? Which you got to move the minus 3 and you got to move the 2, but which one comes first? This is one of those watch out examples that we did last week. We said, watch out, we don't necessarily add or subtract first. We're going to do what? We're going to multiply. We're going to multiply both sides by 2. So those 2's would cancel, so this would be 2y equals x minus 3. Then what would you do to get the x by itself? How would you get rid of the minus 3? Add 3. So I'm going to add 3 to both sides. So I can't add those together because 2y and 3 are not like terms. I'm just going to rewrite them. And so we get x equals 2y plus 3. Now take what we just did and now let's apply it to this example where we have more variables. We don't have numbers in that place. How are we going to get x by itself? What are we going to start with? Multiply by a b, right? So multiply by b on both sides. So that's going to give me b times y, or by, equals x minus m. Add m, Again, by and m are not like terms, so I'm just going to rewrite it as by plus m, and then I'm going to have equals x. So there would be my answer for solving that equation for x, getting x by itself. Any questions there on example 2? All right, we're going to come back to example number 3, but I want to do a few more before we try example number 3. So we'll call this example number 4, but we skipped 3. That's okay. We're going to come back. Example number 4. Let's say solve for A. Let's see, let's go with 5 minus 2a equals 10. Oh, no, 10. Let's make this 10b. So we want to get that a by itself. How are we going to start that? Subtract 5. Very good. Minus 5. So I bring down my minus 2a. Are 10b and 5 like terms? No, so I'm just going to rewrite them just like that. 10b minus 5. Okay, still trying to get a by itself. How are we going to do that? How are we going to get rid of that negative 2? You say add 5? All right, now if we add 5, then we're going backwards for what we just did. We want to get rid of this minus 2. What you got, Colin? Divide by what? Remember, we want the negative 2. So just the negative 2. So we're going to divide everything by negative 2. So that leaves me with my a. Can 10 be divided by -2?
Yes.
All right, yep, so -5b. Now, when I go to this next one, what does a negative over a negative make? Positive. So can 5 be divided by 2? Does it come out to be a whole number? No, so we're just going to leave it as 5/2. All right, let's do a few more here before we move back to number 3. Let's see. Let's go with um, okay, so we want to solve for x if we've got 2/3 x plus 4y equals 8. Trying to get the x by itself. What do you suggest we move first? I don't know what the question is in the chat, but if you can unmute yourself and ask it, because it's too much for me to try to get the chat up. Okay, remember, we want to get this by itself. So we don't want to move it, we want to move everything else.
Subtract 4.
All right, subtract the 4y. So that's going to give me 2/3 x equals, are 8 and 4y like terms? No, so we're going to rewrite them just as 8 minus 4y. Now this one's a little bit of a tricky one. This is where, how did we deal with getting rid of a fraction like this? We didn't divide, because I don't want to divide by a fraction. What do I want to do? We wanted to multiply by what? Say it again. I can't hear you still. Not by x, we want the x to stay there. We want the 2/3 to go away. Remember we said we could get rid of fractions like this if we multiply by the reciprocal. What did we say reciprocal meant? To flip it, right. So we're going to multiply both sides by 3/2. And I will write that down when mine stops spinning. There it goes. So we're going to do multiply both sides by 3/2. So I'm going to put parentheses here. So what that allows us is here on the left-hand side, the 3's cancels, the 2's cancel, leaves us with just an X. On that right-hand side, what are we going to do with that 3/2? What are we going to do with this 3/2 here? Multiply it, and more specifically, do what? Do I just multiply it by the 8? Both of them. And what's that called? Yep, distributive property. You're right. Good. So we're going to distribute that 3/2. So for the 3/2 times the 8, remember, you can think of this as like 8/1. And you multiply straight across when you're multiplying fractions. What's 3 times 8? 24. And 2 times 1. And 24 divided by 2. 12. So this is going to be 12. We're going to have minus. Then I got to do 3/2 times 4y. Again, you could think of that as over 1. What's 3 times 4? 12. So this is going to be 12y. What's 2 times 1? And 12 divided by 2? So this is going to be 6y. So there we go. X equals 12 minus 6y. All right, I'm going to give you this one to try on your own. Let's see. I'm going to go with actually, let me change this. Hold on. I'm going to change it real quick. Let's make it 9 minus 3n equals 20, 27, and we're going to say solve for n. This is a 27. I'll make it a little better. So 9m minus 3n equals 27. I want you to solve that for n. So try that one on your own for a second, then we'll go over it. Trying to get n by itself. Do we need more time? All right, so let's talk through it. How do we start this solving it for n? Subtract the 9m, good. And minus 9m from both sides. So that gives me negative 3n equals, are these like terms? No, so we're just going to leave them as 27 minus 9m. Then what? Okay, so all of them get divided by negative 3. So let's see, we're going to have n equals, all right, can 27 be divided by negative 3? Negative 9. Now the next one, you got a negative and a negative, what's going to happen? All right, so then 9 divided by 3 is 3 and m. There we go. Technically, if you wanted to, you could rewrite this. I'm not saying you had to, but I'm just saying you could. This is the same as saying 3m minus 9, right? I just changed that order there of those two on the right-hand side. And again, I'm not saying you have to, but it could happen. You could do that if you wanted to. All right, now I want to go back to that example number 3 that was on the guided notes page. All right, so here we go, example number 3. This is back on the guided notes. We want to solve this for x. Solve this for x. Now this one's kind of a bit of a tricky one here. Okay, I'm just gonna say for a second, if I had this, 2 times x plus y, what would you tell me to do? Multiply it. So distribute this 2 to both of those, and you would get 2x plus 2y, right? If I look here what I have in example 3, notice that both of those have an x already. So it's like they already did the distributive property. Well, if I want to get the x by itself, then I can't have the x be separated between the m and the n, right? I only can have one of those x's. So here in this one, like I said, it's a little bit of a tricky one. We're going to do basically kind of distributive property in reverse. We're going to take the x out of both of those since they both have an x. So when I do that, that would look like this. I'd have x parentheses m plus n equals p. So I took the x out and I left me with the m plus the n. Because remember, I only want to have one of those x's to be able to solve for it. Now this is x times m plus n. If I want just the x on this left-hand side, how can I get rid of the m plus n? Remember, that's a whole group. It goes all together. Is x times that. What's the opposite of multiplication? Division. So to get the x by itself, I'm going to divide both sides by m plus n. Those would cancel out. So that's going to leave me with x equals P over M plus N. And that would be my answer. So this is probably one of the trickiest ones, the hardest ones that you might see is where they use that distributive property kind of in reverse of what we're used to. And then dividing by that expression M plus N to get that X by itself. All right, let's do just a few more to make sure that we got it. We got example 7, I think. Let's see. Let's go with, oh, here's a good one. So here's your area formula for a rectangle. Length times width. We want to solve this for W. Get W by itself. How do you think we're going to do that? Divide by what? L. So if we want W by itself, to get rid of the L, we're going to divide it on both sides. So that's going to give me W equals area, or A, over L. Let's see, what about this one? I'm going to go solve for L. Let's go to L plus 2W. So this will be perimeter of a rectangle, 2 lengths plus 2 widths. We want to solve this for L. This is area, or excuse me, perimeter of a rectangle. How do we solve this for L? Any ideas on where to start this to solve it for L? Subtract 2L or 2W? I don't think we necessarily have to do that. Because remember, our goal is to get this right here by itself. 2W. So let's subtract 2W from both sides. So we're going to have our P and W like terms? No. So we're going to do P minus 2W. We'll just rewrite it. Equals 2L. You know, we're trying to get that L by itself. How are we going to get rid of the 2? Divide it. So divide everything by 2. This 2. This 2 is positive. Yep. The 2 in front of the L. Now, I think for the P, I don't think we can divide those, so I'm just going to leave it as P over 2. Then we're going to have minus, what's 2 divided by 2? 1. Do I need to write the 1? Just write W, yep. So we have P over 2 minus W equals L, which is my length. So this was the perimeter of a rectangle. All right, we're going to do one more example. This is going to be the last one. Again, and kind of a formula you're familiar with. So area equals 1/2 B times H. What's that the formula for? Area of a triangle. And let's say solve for H. We want to get H by itself. How do you think we might start that? How could we get rid of the 1/2? All right, what do you want to multiply by? By A? Remember, we want to get this by itself. We're trying to move the 1/2 and the B to the other side. How do we get rid of fractions like this? We multiply, but multiply by what? 2, the reciprocal. We're going to make it 2 over 1, or we're just 2. So multiply by 2 on both sides. So this is going to be 2A equals B times H. Again, we're trying to get H by itself. How am I going to get rid of that B? All right, is this a plus sign between them? All right, what is it? Divide, right? This is multiplication. It's B times H. So to get rid of that B, I want to divide both sides by B. So we get H equals, are A and B like terms? No, so we're just going to leave it as 2A over B.